This is Dennis Sullivan, Motion. In our last demonstration, we concentrated on the size 8 PST. Now we're going to move to the size 11. Now, first let's go to the motor setup. I'm on axis 1, PST11, and we're actually going to demonstrate home on an inductive prox in this demo. We're also going to demonstrate the size 11 jam detect. So let's go to setup, and I've set the motor up for, that seems to be incorrect, so let's make some changes. Let's set the nominal current for this particular motor. This is data sheet, that's at 1 amp. Peak current, let's take 1.4 times 1, so let's go 1.4 and 200 steps per rev. 512 line encoder, US digital E8P, and the power transmission is for every rev of the motor we're going to go 5.08 millimeters. Let's go to drive setup. Drive setup, let's take a look at the current controller, and let's take a test current of a 1/2 amp and a protection at 1.4, so let's click test. And let's give it a reference voltage, and let's look at the magenta colored motor current. The pinkish colored motor current is going to come up. It's going to show the actual current rise responding to a voltage reference, the lighter colored curve. And you can see that what's happening is we're coming up to almost up to our current in about 1.5 milliseconds. That's close enough. Position controller, tune and test. Now in this move we're going to make some small moves, and we're going to look at the response given the KP, KI, and KD. So we're going to make 2 millimeter moves. I'm going to repeat that any number of times until I click stop. Alright. So watch the center actuator, the size 11 actuator. It's launching its test code, and it's moving in and out at about 2 millimeters. So let's click stop and capture a picture of the command versus actual and see how nicely this guy servos. So you can see that this curve is just about as good as it gets. It doesn't overshoot too much. That's fine. And it doesn't really come up to, doesn't integrate up there as nicely as I'd like. Let's increase the proportional from 75 up to 80 and see if we can't get some more response out of this guy. So we're initiating the test. It's cycling, and I stop. It's going to capture that curve given a KP of 80. Top curve looks okay. And a bottom curve, it looks like we need to add some integration. So let's make that 5.5. Up from 5 to 5.5 and see if we can't clean this guy up. Stop. Capture that curve. Looking okay on top. Well, let's see if it integrates up. And it integrated up nicely. Now I could refine that even further, but that's close enough for now. Okay. Looks like an encoder click or so off, which is just fine. It's not perfect. So I'm going to click OK here. I'm going to download the setup. Once the setup table is downloaded, I'm going to download the program. Before I do that, let's take a look at the settings. Let's look at some of these variables. So first, I use the tool within EMS to see how many DSP counts there are for 1.4 amps of torque. And I set this guy up in torque mode, and there it is. So for 1.4 amps, we've got 12,625 counts. So what I've done is I've set my peak current up at exactly that, 12,625. Okay, so that's my peak current. Now when I go over to, when I go down into the main program, it's going to run, it's going to go to main loop, and it's going to go to jam detect, and then it's going to go to home and see if I've asked for home, and if not, it's going to go back to the main loop, just go in a circle. So the only two things that are going to trip this guy up are if it jam detects or if I've asked it to go home. Otherwise, it's just going to execute whatever moves I send at it. These are moves that are sent via Cool Terminal or your C++ or LabVIEW program. Either NightAP commands or pass-through commands directly in TML. That stands for Technosoft Motion Language. Alright, so let's download the setup again. Not really required, but I do it in order. Okay, now let's download the motion program. Now the homing routine that I've selected here is a home on a negative limit, and let's look at the homing routine down here. If I ask for a home, it's going to go to this homing routine, and here it is. After I do some setup, it's going to call homing 21. Well, homing 21. Let's read that. Homing without an index pulse. Home switch input is limit switch negative. Initial movement is positive if you're in the home limit, if the home limit is low. Otherwise, it is negative. If moving positive, wait until either the home limit high-low transition or the positive limit switch, then reverse motion. While moving negative, stop at the home switch, high-low transition. Well, all that's going to mean is it's going to go to the home limit. If you're in the home limit, it's going to move away from it until it transitions, or if you're out of the limit, it's going to move negative to find the limit. So we've downloaded this program already, so it's time to move over to Cool Term. And let's power cycle. Since we've downloaded a program, let's power cycle it. Power back up. And we're going to connect. And the first thing we're going to do is see if we have proof of life. Let's do one rel 1 since it's axis 1. Let's move 20 millimeters. Watch the size 11. Okay, so it moved 20 millimeters. And one rel 1 minus 10. Got good motion in both directions. So let's home on that proc sensor. One home 1. And you could see that it came onto the proc sensor and then off. The amount of distance that it came off is another variable set up. If I could type one print, I've told it that my home offset is right here, 1.5 millimeters away from the home. Now it rounds to the nearest DSP, but I've asked it to go, I've set home 1 at 1.5. And let's just set it a little bit different so you can actually see it. Set home 1 to 5, a nice vigorous move away from home. And I'm going to say 1 save. 1. Move 1. 50. Move it away. Now if I say 1 home 1, it's going to come in, find the procs, and then come out 5 millimeters. And that's your offset home. Let's do one print POS, and POS is 0, 0, 0. So let's do one move 1, to 40 millimeters. Out we go. One print POS. So we're at the closest we can get within a DSP count, 39.9976. For all practical purposes, 40 millimeters. That's the closest you're going to get given the resolution of that encoder. Now what I'm going to do is do one print pause error, and you can see that I've got 0 error. Now let's test that. One print pause error. I'm going to put a little bit of force on this guy, and I got 8 counts of error. It's a stronger motor than that size 8, so if I do one print pause error, back to 0. One move 1, back to 0. And let's see if I can't put my hand in here and stop it. And just a little bit of force, I was able to stop it. One print POS, so it moved back a little bit, and then I pulled it back out with my fingers, so it jammed at 40.0844. So let's do a one, moves 1, back to 0. And we're at one print position. We're at position 0. One print pause error, and we're there. And let's do one. Let's jam it one more time. One, move 1. One, move 1, 40, 50. Let's turn it up so we can put a little force on it, holding onto the body. So you can see that I just put a little bit of force pulling down, and I was able to jam it. Let's let it go up a little bit farther. One, move 1, 50 again, up. And I stopped it midway. One print POS, so it got up to 16 millimeters. One move 1 to 40. Let's try it again. A little bit further this time. One print POS. Got up to 25, one move 1 to 40, and it gets all the way up to 40. One print POS, up to 40, one print pause error, and it's 0. There we are.